write out is that whenever you're given a problem, I was asking that you guys start always by circling your angle, drawing to your opposite, and labeling your parts. Okay? And you do that each time. So if I'm looking at 13, I think we did this one in class also. 13, you have an angle. You don't have anything in for the opposite, so which trig function you're going to have to use for 13?
Cosine.
Cosine. So I'm assuming that you guys all wrote this then, that cosine of 55 is your adjacent over the hypotenuse, correct? You didn't do anything else but that. Good. If I look at 15, what trig function am I going to use there? Sine. You're going to use sine. You circle your angle. Oops. Circle my angle. I'm always looking at my opposite. Makes this side my adjacent. This has to be the hypotenuse. So we go through again. Opposite and hypotenuse is your sine. You wrote it out, hopefully. Sine of 50 is 18 over x. And this is what we were working through. Okay? So as we go through these then, let's see. 16, what did you guys use? Which trig function? Just so I say.
Tangent.
Tangent, good. You had tangent of 54 was x over 17. We okay with that? All right. 17, what did we use? Sine, good. Sine of 68 was 18 over x. Excuse me. Getting there. The, what was that? 18, which one did you use?
Cosine.
Cosine, good. Cosine of 75 is 11 over x. 19, what do you get?
Sine.
Sine of 73 is x over 20. Yell if you're not getting the right answer here, okay? 20, we use
Sine.
sine of 56 is 16 over x. 21. Gee, this is kind of boring after a while. I thought I randomized it enough so they would, oh well. And then you get sine of 21 is x over 13. And 22, hey, there's a different one.
Cosine.
The 39 is 19 over x. And we're back to, oh, what do we got for 23?
Tangent.
Good, x over 10. And then 24,
Sine.
all right. Now, with any luck, after we find the right folder, with any luck, you guys notice one of two things happen. If I look at 23, we said that this was tangent. So it was tangent of 36 is x over 10. That's what you guys had, correct?
Yes.
Now, let's talk about the two different ways that we're going to be able to solve these equations. If you look through all of your problems on the back there, one of two things happened. You either had the unknown variable, the x, was either in the numerator or was in the denominator. It was nowhere else but those two places. Do you recognize that? That's the only places it can be right now, because we don't know how to solve for angles yet. We'll do that maybe towards the end of this week. Which means there's only two different cases to solve these equations. It's really only one step. Because I want you to think about this is, we said this earlier, the trig stuff, they're all ratios. Ratios are just fractions, okay? So if I, in my calculator, I press tangent of 36, I get some crummy decimal. And I don't like to write out crummy decimals because you can round them off, you can truncate it, you'll wind up with rounding error, bad things happen, and you wind up on Mars instead of the moon because you didn't turn left in altitude. But what you need to be able to, thanks, we caught that. What you need to be able to look at is how do you use the calculator to make your life easier? So just look at this. How do you undo divide by 10? Times. You multiply both sides by 10. So basically what happens here, if the variable's in the numerator, you always do the same thing. Now, there's a reason why I want you guys to write this stuff out. First of all, if you write it out, you always will put your numbers, any number that you're multiplying by, before the trig function. Because if you look when you press the trig button, what does it automatically open up in your calculator? It automatically opens up parentheses, which means you'd always have to close them. So if you put in 10 tangent 36 instead of tangent 36 times 10, you could get a wrong answer. That's why we always put numbers in front. So, like I said a second ago, there's only going to be two possible ways to do this. Case one. You get this. Some trig value of an angle is x divided by some number. Basically, this means that if x is in the numerator, you do this. You're always, always, always going to write it out as some number times the trig, oops, of your angle. And what I mean by this trig, it means it could be sine, cosine, or tangent. It could be any one of those three. The button, whatever one of the functions it is, it doesn't matter. You still do the exact same math, if you will. You still just move that value from the denominator over. That's it. So basically what happens then is that in your calculator, I don't think anybody in here is using a graphing calculator, but real quick, just in case you do screw something up by it from time to time, which never happens. Of course not. If you read on here where it says textures and instruments, the last couple of letters, the INTS, or the NTS, excuse me, there's three letters underneath that says DEG. That stands for what mode your calculator is in. That means it's in degree mode. In geometry, that's the only mode that you ever have to worry about. You're never going to use any of the other modes. If you hit the button that says mode, you'll see that there are three different ones. There's degree, DEG, radian, which is RAD, and then DRAD, I think, or grad. Yes, ma'am.
So we're using that formula only for the tangent?
Oh, you can use it for any three of them.
Oh.
Basically, what I'm saying here is if you look through your sheet, you're either going to have a variable up top or a variable down below. If the variable's up top, it doesn't matter what this thing is. It could be sine, cosine, tangent. It's always going to be the same setup. So I forgot what that stands for, but don't worry about it. You'll never use it. Radian mode you'll use next year in Algebra 2 a little bit, not too much. My honors class, we use it, that's all we use. And then in pre-calc, depending upon levels and stuff like that, using different stuff. Radians are actually really easy to work with. So if you have, I think most of you guys have the multi-view calculator, they're automatically going to be reset themselves to that DEG. If you do want to take your friend's calculator and mess with them, change the mode, because then they'll get negative answers and they won't know what's going on, and it's kind of funny. So, oh, did that to you? Smart move, actually. It's always kind of fun to mess with people like that. Don't do it on a test, though, because then I'll feel bad. But then the other thing is that this also goes into play with why I always want you guys to write down what you're going to put in your calculator before you put it in your calculator. Because if you happen to be in the wrong mode, you're going to get the wrong decimal answers. But I will know that you knew what you were doing. You just pressed the wrong button. Okay, does that make sense? Or somebody did the wrong button for you, right? Now, the other thing is, if you go to your calculator, you type in 10 tangent 36 and hit enter, you get a decimal. My standard thing for you guys, whenever we're rounding with decimals for this kind of stuff, is we're always going to round to the nearest hundredth, which means we always look at the third number. Is that third number in this case a 5 or greater?
Yes.
Yeah. So what do I round this to become?
7.27.
I'm going to two decimal places, so it'd be 7.27 is what I would round that to. Okay. So whenever we round, I'm always gonna ask you guys round to 2 decimal places. And that's what you would do, okay? Now, here's the deal. If by chance you accidentally, I knew that this would equal x, what happens if you hit cosine real fast instead of tangent? Look at the subtle difference. 10, if I just accidentally hit cosine without paying attention, I get 8.09. If I wrote down 8.09 with all of that work, I could easily figure out what you did wrong. I know you did the right thing. You told me you were doing the right thing. You told me that you're going to type in your calculator tangent 36, but if you accidentally write down a different digit, I could backtrack it. I could figure out what button you pressed. Did you accidentally press cosine? Did you accidentally press 32 instead of 36? Did you do that? I can figure that out. And I'm not mad at you for pressing the wrong button, because this is the key. Yes, ma'am?
So in the calculator, you put 10, then tangent, and then 36 in parentheses?
Yes, ma'am.
Okay.
That's all it is. Whenever the variable is in the numerator, you just move that denominator over in front of whatever trig function it is. Whether it's a sine, a cosine, or a tangent, you do the same thing. That's why I generic it out with that, as I call case 1. Not terrible? Let's look at the other case. The other case is when you have the variable in the denominator, like on 22. I'm guessing with 22, you guys, if I'm not mistaken, you guys all told me this was going to be a cosine problem. So you guys had the cosine
Here it is.
of 39 is 19 over x. Okay. That's what we wrote out before. Well, before I get into what you're going to do mathematically here, I want to show you guys again what happens when you have ratios and proportions. Because the cosine of 39 is this ratio of 19 divided by some number. I don't know what that is, but whenever you have two things that are set equal to each other as fractions, they're always proportional. If things are proportional, like we did back in chapter 6, you can do this. Is that true or false? It's true. And if you remember, you can exchange things on diagonals, and it's still true. Remember that? So if I flip-flop, exchange-o, change-o, the 3 and the 2, I would get 2 over 6, which is 1/3. Is that true or false? It's also true. So basically what happens then in case 2, when the variable's in the bottom, all you have to do is an exchange-o, change-o.
So split it.
You know, there's a machine in the back that'll do that for you. You know, that's very nice of you. So here's case 2. You have some trig value, I don't know which one, and it's some number divided by your unknown. When you have some number divided by the unknown, you're always, oh, well, before I do that, does this change the problem?
No.
Yes. How? Okay, I added a 1, but does it mathematically change the problem?
No.
So here's what you can do. Bless you. All we're going to do is exchange-o, change-o. X is 19 divided by the cosine of 39. That's all you do. You exchange-o, change-o. That's it. It sounds stupid, but it works. Exchange-o, change-o.
I thought you had actually written that.
Oh, exchange-o, change-o?
I was going to start watching. Do we still put case 2 in like calculator?
What's that?
Do we still put like for case 2 that like we put the equation in the calculator?
Yeah, so now all I would do here with in my calculator is this. I would type in 19 fraction bar cosine over divided by the cosine of 39. It will look just like this then. 19 over the cosine, what was it, 39? And I hit enter, and there's my answer. When I round that to 2 decimal places, what do I get?
24.45.
24.45. There's only 2 ways to solve these problems, guys. Variables in the numerator, variables in the denominator. That's it. If you know your angle measure, there's only 2 things that can happen. One of those 2. And it's just, you do the same thing each and every time. You just ask yourself, is it case 1? Is it case 2? That's it.
So now it's our
No, I want to practice this first.
this is easy.
Yes, ma'am.
Why didn't you use that sign for angle?
You know, it's a more proper, instead of saying angle, a lot of times when you get into algebra 2, when you start talking to the more, I don't want to say perfect, but the math, you ever heard the term math etiquette?
No.
Math etiquette, it's one of these things that,
It's made up word by math teachers.
yes, that's the symbol for an angle in upper level math. And I think it looks cleaner than just writing x here, because a lot of times our value of x could be, right now we're worrying about it being a side length. Eventually we'll find the angle, and by using that symbol, that symbol's only ever used for an angle. That's why I decided to use it this year. I've never used it before like that. I just thought it was nice. Instead of saying, I mean, you can do this and say trig angle. But I think that's just a cooler. Alright. Because then next year when you get to algebra 2, you're going to find this value of theta between certain certain quadrants using trig functions. Alright, I'm a nerd when it comes to a lot of this stuff. Trig is one of the things I absolutely love to teach. It is one of my favorite things to do. Because within trig, a lot of times, there's actual practical stuff you can use out of it. I know it's hard to believe. And one of the things we do, as that you'll see tomorrow, is one of the big application things that we use. Questions then? So I want you guys to do the following for the next, I don't know, 5-10 minutes or so. On your sheets that you guys have, you already have everything written out. You've got all of your questions like on 19 and 20. You have it written out in terms of your trig function. You have it written out as, you know, sine of, like on 19, you already have this, sine of 73 is x over 20. You have that. Bless you. Bless you. Third time's a charm? Okay. What I want you guys to do, is go through the 12 on the back there, less than the ones we just done, and rewrite them now to solve it. So here, is this case 1 or case 2? Case 1. So that means I take the 20 and put it in front, and then I type in my calculator. But I want you guys to show this step. I want you to write that out. Don't be surprised if there's a time that I'm going to ask you guys to take a quiz or something like that, not use a calculator whatsoever, and leave your answers like this before you get to the calculator. Because this, if you can do this 4 or 5 times without an issue, you've mastered it. Quite literally, you've mastered it then. Because the rest of it that we build out of there, it becomes even easier. Okay? It's just a matter of getting used to it. So, take the next 5-10 minutes. We'll check them in a minute, and I do have a couple more like this for tonight. Yes, ma'am.
I just have a question.
Excuse me. We can do this quietly, please. The reason why it spits this out is because 75 can be rewritten as 45 plus 30. You have what are called sum and difference angle formulas. And those are when you can add together, basically what happens is you've got 4 main angles that you use for trigonometry. 30, 45, 60, and 90. All the important angles in trigonometry are composites of those 4 numbers. So what happens is that you have this formula, that takes the cosine of 75 and splits it into those, which basically does this then. You have the cosine of 45 times the cosine of 30 minus the sine of 45 times the sine of 30. Well, trigonometrically speaking, this is root 2 over 2. This is 1/2. This is root 3 over 2. This is 1/2. So you get root 2 over 4. And root 3 over 4.
So we can't just do the little double arrow thingy? Or no?
Yes, this is a pre-calc thing, but
Oh, so I can do the double
yeah.
arrow? Okay.
So when you see, and the reason that you're going to see that, you're going to see weird answers like that when you have 75s and 15s.
So then we just add.
So you might get some weird ones. So if you get that weird answer, just double arrow it.
And then just add those two together.
No, just hit the double arrow button. You're done.
Oh.
If you get a funky answer like that, just double arrow it, and it'll automatically spit it out as a decimal. But the reason, I'm just saying that the reason that it's doing that is because there's these things called sum and differences of angles.
Just checking, I think 43, right?
No, rounding 2 decimal places.
Okay.
So it'd be 42.50. Okay? Guys, please, do the work. Come on. Leave them alone. Where's your stuff? Come on. This is, you guys know better than this. I shouldn't have to tell you guys this every single day. Or you guys really need to get split up. We'll see how we did. Thanks, sir. Now, hey guys, remember, you guys already have done the majority of the work for this. You knew that this was the sine of 68, bless you, is 18 over x. You knew that from last week. Now, what I'm asking you to do is decipher, is it case 1, case 2? I'll let variables in the bottom, so it is
Case 2.
case 2. So that just means I have to do the exchange-o, and then I write it down before I press the button in my calculator. Okay? By writing it down, it'll show you what to do, because then you just make your calculator look like that. And if it doesn't, you done goofed. All right? And it's just a matter of rounding out 2 decimal places. Okay? Questions on that? Let me give you some more of these to work through. Then I want to show you exactly how I want the work to be done for tonight. You guys to do is this sheet of the 24 of them, but I want you to set it up in such a way. I'm going to look at number 2 to show you how I expect this to be done. So what do you think the first thing I'm going to have you do is? Circle the 21, and then draw to my opposite, and this is my, and there's my hypotenuse. So the first thing I want you to do is label your triangles, just like we've been doing. After that, what trig function am I going to use to solve for x? Knowing an opposite and adjacent. Tangent. So then I would write, well, that means that the tangent of 21 is 15 over x. Is that case 1 or case 2? Case 2. So which means I do an exchange-o, and then I round it 2 decimal places. Okay? That's what I want done. It's very systematic, it's very simple. I do recommend, make sure you have your sine, cosine, tangent stuff written down, as well as case 1, case 2. Because every problem is going to be solved via case 1 or case 2. It changes ever so slightly when we look for angles, but we'll get to that towards the end of the week. I have on there for Friday a quiz over where we're at this week. Depending upon how far we get is how much we'll have in the quiz. And we'll know more of that come Wednesday into Thursday without a problem, okay? Your quiz grades, I think I mentioned this as you guys were walking in, just some of you guys did really well on that quiz. You really did. There was only a couple of little silly, stupid things that happened from time to time, but other than that, It's a very easily fixable situation. So don't fret, all right? Well, you should get those back in your hands. My guess is the latest on Wednesday, because I got a bunch of people taking them tomorrow. But as you know, everybody's been dead sick this past week or so, so it's been a little tough to get things in. I know. All right? Questions? Yes, ma'am. Yeah, go ahead and grab one, okay? Thanks for reminding me. What's that? Tomorrow? Oh, no. Because I don't think we'll be up here in time, because we'll be down in the auditorium, then we're just gonna come right up. Yeah, no, you'll be fine. I'll just email and say you're there. That's okay. Yeah, and remind me tomorrow to email your flex teacher, but that happens from time to time, and they don't usually mind, especially if you're making up a quiz or something.